Hello guys, in this video we are going to discuss the problem A1 and problem A2 from the code forces round 843 that was rated for Dev 2, and the problem's name is Garden in the Capybaras, easy version. So there's a hard version to it, that's the problem A2. The only difference between the two is that the length of the string can be bigger in the harder version. But anyway, the solution I'm gonna give is pretty optimal, so it will work with both the scenarios, and it's also easy. So there's a lot of information given over here. I won't waste your time reading out all of this information. If you're already on this video, I'm pretty sure you have actually read it. But anyway, the gist of the problem is that there are three lines A, B, and C. So let's call them X, Y, and Z because actually it's causing a lot of problems because the letter itself are A, B, A, B. So let's call them X, Y, and Z, right, for our convenience. So what they're saying is that you have to extract X, Y, and Z from a string that's given to us, and either of these two constraints should follow. Okay, so the first constraints that available is, okay, so A is less than equal to B and C is less than equal to B, or in other words we can say that B is greater than or equal to both A and C. If this constraint is followed, then a string is good. Otherwise, at least this constraint should follow, right? Either one of them should follow. So the other constraint is that B is less than equal to A and B is less than equal to C, or in other words B is less than or equal to both A and C. So if any of these constraints follow, then a string is valid and we have to print it out. So with that, let's get started. Let's try to understand what's happening. So let's say we have a string S, right? So let's call it S, and we want to derive X, Y, and Z. So these X, Y, Z are basically A, B, C. I'm changing their names because there's a lot of literals A and B in the string itself, so I don't want to confuse you guys. So just a second. Cool. Okay, so what we are doing is that, let's say this is a 0th index. I hope that made sense, right? And this is the n minus first 1 index. Now since the strings are non-empty, so 0th index would definitely always be in A, right, or in X, sorry. So 0th index would always be there in X, and the n minus 1 index would always be there in Z. Now what about Y? Y could have any of these values that are from 1 to n minus 1. Now let's say Y starts from 2, then this first index also would go to X. Or if Y ends at, let's say, something like n minus 3, so the index is n minus 2 would go to Z. So yeah, that's pretty trivial. That's definitely something we know. Also, let's see how they have actually defined something being smaller or something being greater. So yeah, give me a second for that. Cool. So what they have said is that, okay, over here, so a string X is smaller than Y if X is a prefix of Y but X is not equal to Y. So for example, we have two strings A and AA. So A is a prefix of AA, right, but A is not equal to AA. So in that way we can say that A is less than AA. The second is the basic definition. So we start counting from left, and whatever value comes first, that is not similar in both the strings, so we take the minimum value for consideration. So I think that was pretty trivial. Let's move ahead. So what we can say is that A, so if I have a single value A, so it would be less than or equal to all the other possible values. Now A is less than or equal to AA, it's less than or equal to AB, B, BA, everything it's less than or equal to, right? So this is something we know. What more? So B is greater than or equal to all the possible values, or not B but B followed by some strings, right? So B, okay, so B actually is greater than A, and B is also greater than or equal to B. This is trivial, no need to say this. But what if I have B followed by any number of characters, right? And let's say all of these characters are B. So these are two things. Like now all of the characters I am having are B itself. So they would be greater than or equal to A and B itself, right? I hope this made sense. This was an easy observation. So now what I can say is that let me try to find if I can make B equal to this, because if B is equal to A, or Y is equal to A, then in that case I can satisfy X is greater than equal to Y and Z is greater than equal to Y, because we know that A is definitely always the smallest, or equal, like something can be equal to this but cannot be smaller than A itself. So if I am able to find a within the range 1 to n minus 1, that was n minus 2, that was the range for B, or for Y, Then in that case I can say, okay, so my string would be, I can start from 0. I can take it, like use this particular string till the time I'm able to find a, right? And I can call the string x. Then I can take up all the values over here and I can call this z. So that's the first case we can do. Now what if it's possible that all the values from 1 to n minus 2 don't even contain a? So in that case, so it's similar to saying that all the values in 1 to n minus 2 are actually b's, right? If they don't contain a's, the only option we are left with b's. So in that case I'll say my y is actually equal to this, right? Now my x and y, x and z would only be of single character. So they could be anything, they could be a's or they could be b's, right? Similarly even z could be a or b. So if, now this condition would hold true. Y is greater than equal to x and y is greater than equal to z. I hope that made sense. So yeah, this is exactly what we need to do. Let me show you the code. So over here you can see that what I'm doing is that I'm checking from the index 1 till the time index n minus 2. So if I'm able to find a, then I'm setting my position value to that. So now I'm checking if my position value has been set, so that means it's not -1, that was its initial value. Then I can print like all the strings that's to the left of the first occurrence for a, that would be my string x. Then I can print a followed by whatever string was there to its right. Now what if I'm unable to get any a's in it? Then the answer simply would be the 0th character would become x, all the remaining string. Now this would be the string that would contain only b's, right? So these b strings followed by the last character that would get assigned to z. So yeah, that's simple. This was actually the solution you require. Also you can check the code. So I submitted the same code, I guess. Let's see that. Cool. So yeah, this is the code I used. Now let's try to copy it and use the same code for a2 as well. So now over here, since our time complexity is order of n, so this should work for both the strings, because over here the length of the string was 10 to power 5, and this shouldn't give a problem over here as well. So the same code would work for both the problems. Let's try to submit it up. Okay, you have submitted the same code over. Yeah, so I've submitted actually the ssame code, and it had already worked. So you can see over here a2 had a right summation, so the code was same. So I thought, I guess like you got the logic. If still you have any doubts, you can let me know. I'll be more than happy to answer them. Thanks guys. Bye bye.